So this first one, we're going to put them in brackets, right? And then we rewrite it for GCF and difference of squares if we can. These are monomials, so there's nothing you can take out because there's no terms, right? So the only thing we can do is write them separately. So we can go 18, and then x to the 4 if we want. I don't know why that bracket looks so awful. I'm just going to erase that. X to the 4, we could technically write as 4x's, right? Because x times x times x is x to the 4. So we can write it that way. And then we have 36, and then x to the 7. 1, 2, 3, 4, 5, 6, 7. So if we want to, we can write it all out like that. X is all separately, right? Before I go to cancel anything off, though, what do I have to do? NPVs. So, can 36 equal 0? No. So do I actually have to say 36 cannot equal 0, or can I just be like, that doesn't get me an NPV? Yeah. So I don't actually have to write that because I don't get an NPV from it because it's a number. You only get NPVs, non-permissible values or restrictions, from variables, right? So I have an x by itself, so I can say x can't equal 0. So that's true. Do I have to state it 7 times, or have I covered it? I've covered it, right? X can't equal 0. So if I filled it in for any of those, I would get a 0 in the denominator. So I've covered it. I don't have to write it 7 times. I don't have to be like x can't equal 0 7 times. Just once. Okay? Then I have to twin in the numerator and twin in the denominator in order to cancel. If it's twinning in the numerators, they can't cross each other off. If it twins in the denominators, they can't. It has to be one on the top and one on the bottom, right? So I can go this one for this one, this one for this one, this one for this one, this one for this one. The only thing I told you that you can get away with not twinning is if it's coefficients. So just numbers and brackets, correct? Those are the only ones that I said don't have to match perfectly, but I can reduce by taking something out of it. Okay? So if I have 18 and 36, is there something I could take out of both of those? 6, something bigger? 9. So I can take a 9 out. 8 divided by 9 is 2. 36 divided by 9 is 4. So on the top, I'm left with 2 times 1, 1, 1, 1, 1. So that's just 2. And then 4 times 1 times x, x, x times 1 times 1, 1, 1, 1, 1. So I have 2 on the top, and then 4. Oh, look, could I have done more? Perhaps. What is this? X to the what? 3. And then I look and I say, oh, darn it, I didn't reduce enough. Is that the end of the world? No, it just means one more step. Had you done 6, you wouldn't have reduced enough either. Wouldn't be a big deal. You'd see in the next step you can keep going. Totally fine, right? So I can take a 2 out of both of these. And I get 1 over x cubed. Because 18 and 36, I could take 18 out of both. Then remember, I have to follow behind with x cannot equal 0. Do you see these equal signs I have here? You have to put them. Because what you're saying is this expression equals this expanded expression equals this simplified equals this. Yeah.
I feel like I'm doing something weird, but I'm getting the same answer. I took a 6x to the power of 4 out of the, like both of them, and then I crossed those off, and I got 3, and then over 3x cubed, and then crosses the 3's off, so it's still 1 over.
Yeah, you just GCF them out. Totally
so that's
fine.
Okay?
Yeah.
Okay.
Yeah.
What happened to the 2?
What are you talking about? It's been there the whole time. Go back in the recording, you will see it wasn't. But I'm magic, and it just showed up. It came late to the party, okay? It just didn't want to be there on time. All right, so let's look at B. So for B, what can I take out of the numerator? A 3y. So I take a 3y out, and I'm left with, what's 3y? Take out 3y. Does it just evaporate? No, I'm left with a 1. Because when I take a GCF out of 2 terms, I better still have 2 terms in the brackets, right? One of those terms just might be a 1. And then negative 9y squared, take out a 3y, I get negative 3y all over 6y cubed. Then what did I tell you can do with the 3y and the 6y cubed, because they're not attached by plus and minus signs? Subtract. Now this 6y cubed, I could actually rewrite this. I could go 3y, 1 minus 3y, over 6 times y times y times y. And then I see that there's stuff I can cancel off, but what do I have to do first? NPVs, always. So my NPVs, do I have to say 6 cannot equal 0? Do I have to state that statement? No, because it doesn't have a variable, so it's not going to get me an NPV. Then I have y cannot equal 0, and that one's done because it's already in y equals form. Do I have to do it 3 times because there's 3 of them? Nope, I only have to do it once. Okay? So what can I cross off here? A y for a y. Sounds like an I for an I. It's not the same thing. A y for a y. And then 1 minus 3y. I can cross this little y off behind the 3y with this y, can't I? No, that's just foolish and silly. Why can't I do that? Because it's attached. 1 minus 3y is in brackets, correct? So that's sewn together. So the only way 1 minus 3y is going anywhere is if I have a matching replica of 1 minus 3y in the denominator, which I don't, so it's staying for life. I can't reduce it. Okay? What about the 3 and the 6? They don't match. Do they have to match? Do they have to twin if it's just numbers? If it's just numbers, is what I was going to call them. If it's just numers in the front, that silent B. Can we reduce them? Yes. The only place we can reduce if they don't completely match. They're not twinning. So I can take a 3 out of 3 and I get a 1. And 6 divided by 3 is a 2. So then I write what's left over. If I didn't reduce it fully, you'll figure it out in the next step. It's not a big deal. You just end up with an extra step if you forgot to reduce it completely. So I have 1 times 1 times 1 times 1 minus 3y. So I have 1 minus 3y on the top. Do they have to write it in brackets in their answer on the diploma or on the unit test? Do we have to have those brackets there to represent that it's 1 minus 3y just sitting there? You only have to if there's something in front of it. So if there was like an x in front of it or a 2 in front of it or a 4 in front of it, then I'd have to follow behind with 1 minus 3y in brackets. But if it's just 1 minus 3y in brackets, I could write it with brackets, or I could just write it as 1 minus 3y because it's by itself, right? The only reason why is because it's by itself. So I could write it in brackets or not. The bottom, I have 2 and then y squared. I could write it like this, or I could write the 2 and the y squared in brackets by itself in the answer. Okay? So you can get rid of those brackets at the end if it's a monomial, which this one is, or if it's only one term, 1 minus 3y up here. But I could also write it like this as a written response, and I'd be completely correct. Okay? But on the actual multiple choice, they won't have those brackets. So don't let that freak you out. And then we follow behind with y cannot equal 0. C. What can we do to the top on C? Take out 3a squared. 3a cubed, take away 3a squared. I can't problem solving. What's left? A 1 and a a. Do I need the 1 if I have the a? Do I have to go 1a? Or could I just write a? I could just write a. I can write 1a. Both of those options are correct. Okay? Just because it's a 1. Because 1 times anything is itself. So that's why we don't have to write that. And then minus 3a squared, take out a 3a squared. 1. Do I have to write that one? Yes, because it doesn't have just a variable. And I need to have 2 terms. And remember, when you take a GCF out, you can check and see if you did it right. I can pretend to distribute it back in. 3a squared times a, 3a cubed. 3a squared times negative 1, negative 3a squared. I know I'm good. I'm happy. And then these ones I can put in their own brackets. Over. What can I take out of the bottom? I can take out just a 12. If I take out just a 12, I'm going to be left with negative a plus 1. And I need it to be positive a minus 1. So I need to do the complete opposite sign. So I shouldn't take out a plus 12. I should take out a negative 12. Right? Once again, if you took it out and you found that they don't match, then go back and take out a negative 12. Not a big deal. So I take out a negative 12, and then I'm left with 1a minus 1. Now I see they match and I get super excited, but I have to stop myself. Correct? I have to do NPV, so restriction. So do I have to write the negative 12 can't equal 0? No. Do I have to go a minus 1 can't equal 0? Yep. Add 1. A can't equal 1. And these can cancel off because they completely match. Why didn't I write the a squared out twice on the top? There's no separate a's in the bottom to cancel off. So I just didn't take the time to expand them, but I 100% could have went a times a. There's just no a in the bottom to cancel off. So if I went a times a, I'd have to just put them right back together again. So I only didn't separate them because there's no a's in the bottom. And then I have 3 and negative 12, which I can take a 3 out of. 3 divided by 3 is 1. Negative 12 divided by 3 is negative 4. So I get a squared in the top, negative 4 in the bottom, and a cannot equal 1. And I just want to show you one other way they could write this, just in case. I don't think they will, but they could. If I just have a number in the bottom, they can bring that number out to the front to make it a fraction. So instead of writing a squared over negative 4, they could write this as negative a quarter a squared. I don't foresee this happening, but I just don't ever want you to write it final and then get something that you've never seen before. Yeah.
Could you take out a negative 3, like write the negative sign to the numerator?
So negative signs can move around. As long as you have one, it doesn't matter where it is. So another thing, that's a really good comment. So instead of having a squared over negative 4, I could, on the test, if I have one negative, I can move it around. But I can only have one. So I could actually move it to the top too. So I could write it like this. The other option I have is I can write it completely in front. These all equal. So that negative sign can move around. So don't let it throw you off on a test if I have it on the bottom and you have it on the top, because you could move it to the bottom. Yeah. And the reason why you can is because you could take that negative out. That's exactly why the negative can move. You're right. Okay, we're going to flip over. And you're going to work on all those questions. Get working.